Today I'm going to talk about the SQL injection. There are a lot of help available online about the SQL injection, how to mitigate it and what it is actually. But today's video is for the beginners as well as for the advanced one. If you are a beginner, it's a great way to start and look into it, how to avoid it. And if you are at advanced level, then I can go one step further to explain about it and how to mitigate it. And also I'm talking about second order SQL injection as well, which is equally important. Like normally you only get know about like a normal SQL injection, just putting the escape codes in it and how it works. And then I will talk about like the WAF as well, how WAF can prevent this one, and how hackers can exploit the WAF as well. And then I will cover our very important topic regarding the exam, not exam, like sorry, interview questions. Like if you are going for an interview as an AppSec engineer, SQL injection, I'm sure like is the first one which will come up in that interview call. So it's very important for you to stay with me, and I will go through that in detail with you. Now let's have a look the SQL injection vulnerability and how the hackers exploit it. Obviously, like first they have to understand the input fields. What they do is like identify in input fields in your application, like the login forms or search box, or if you have any URL with the get parameters. Those are the areas which they look for first. So once they identified the input fields or a form, the second form of is the testing the user, like the input field. So what attackers do is they pass some parameters like a single quote and double quote in that those fields and see how the application react. If they get a result like a SQL syntax error indicating that the input is being directly inserted into your SQL query, and that's where they get the idea. Okay, this form is vulnerable to the SQL injection. So the third step is crafting the injection. The first one is like authentication bypass, just adding like that simple values in the input field, single quote or single quote one is equal. So obviously like when you put this thing into your query, and if you are using a concatenation, so where the query become like SQL select static from users where, and then this whole string is that obviously like one is equal to one is always right, and that's where they bypass the authentication and user logged in into an application. The second one is the data retrieval, where they use the union, just put the single quote in it, and then add the SQL query in it, like the union, select user passwords from users table. That's how they get the data. Obviously, like when we design our database, we normally use the same table names, select strategy like a users, orders, and all those kind of a things. So that's where they get an information in to the data retrieval. So there are three main pillars of SQL injection exploitation. The union base, which we just covered it up. This technique involves using the union SQL operator, obviously, to combine the results of two or more tables. And the goal of this injection is to retrieve the data from other tables within the database. Just taking an example, like in previous ones, where the hacker can get an information from your order table. They can get the username and passwords from the users table, and there are some other information they can get it. The second one is the error based SQL injection. That is like kind of I would say it's very tricky to execute this one, but it is still something which is already there. Like what attackers use like a SQL error to gain information about the database structure. For instance, like injecting single quotes and double quotes. This could cause an error, and that reveals the database version. Like if you are not using proper output, like exceptions handling, and that's where they get this error message, and they knew it like it's vulnerable to SQL injection. Okay, the third one is the blind SQL injection. So when an application does not display any SQL error, like you have your exception handling in place, attacker uses the blind SQL injection option. So this involves sending a payload that causes the application to behave differently based on the SQL query result. For example, testing for true or false conditions, like how the application behave, like how long. So for example, if they send a one query, and that will take like a 1 second. they send a second parameter like a false parameter and see how application react to that one. If that takes like 10 seconds, that's where this blind SQL injection happen, and then the obviously like the one we just have like in the middle, error based SQL injection. Let's have a look like how this whole thing happen. Let me move myself out from the frame so that you can see the whole screen. So exploiting like a database error to extract sensitive information. So over here you can have a look the vulnerable query, select static from product where id is equal to the input where user input the values, and if I put this id 1 colon, that return a single product, whereas the attack injection is select static from product where id is equal to single quote 1 single quote. That will give the error at line 1. So that's how, so that's the step which they follow to exploit it. First, they test the vulnerability by inputting one static that gives the SQL error. Extracting the database information and convert this string. This gives you reveal the SQL version of it you are using. The third one is like listing tables, one static and then count from your schema tables that provide the count of all the tables, and then getting the table names again, like select table name and then like add the information, gives you the first table name. Obviously like they have added a limit over here to get like a one by one information, and then this last step is like extracting data from the tables. So that's where they add the union in it. So you see like it's not like a one step, it's they starting with the one thing, and then they did it like at multiple levels, where they start with the error and then like use the other one like as union to get the username and passwords of the users. So let's talk about the mitigation techniques, like how to mitigate the SQL injection. There are a lot of ways you can do it, obviously like the prepaid queries is the one and the most recommended way. That was actually we call like a pre-compiled SQL queries with placeholder and preventing malicious code injecting by separating the data from the command. I will go through this thing in a minute as well to explain a little bit more about it. This second one is obviously like you can use the stored procedures as well. Encapsulate the SQL logic on the database server, reducing the attack servers and then enforcing the secure data access. And then the third one is obviously like one of the most important thing, the input validation. So regardless, like we are talking about like a SQL injection or we are talking about any other type of vulnerability, cross-site scripting, server-side forgery, you name it, that all start with this input validation. If you are not validating your input, then it's a chance you are vulnerable to one or the other vulnerability. So it's very important, like to validate your input and verify it based on the values you're expecting in that field. Obviously like object relational mapping is another one which you can use to mitigate the SQL injection. Escaping user input, again, once you validate the input then you should escape it as well. I will come back to least privilege in a minute. WAF is another way you can stop, but I will in later I will cover up like how hacker bypass the WAF. So WAF, sometimes user thinks they have an application behind the web application firewall, so the WAF will handle all the SQL injection and all those vulnerability, but that's not right. Like there are a lot of ways you can bypass the WAF. Regular security audit and code review is the must thing. You should use some code scanning tools. There are a lot available around it now, and obviously like the error handling. Make sure you are not displaying error to the user. So the one which I just mentioned, like I skip for now, is the least privilege. If you look into my if you watch my other videos, you will see like in every video I talk about like the least privilege. That is kind of like a very basic or very core function of the secure design. You should not give user permission which they are not expecting. So regardless of your application, regardless you are working on AI or without any AI application, code design principles stay same. and least privilege is one of the most important one you have to take care whenever you're designing an application. Okay, how parameterized queries solve SQL injection. So this topic is very important when you as a beginner learning about it. It will be very handy for you to get your concepts right. And if you are like advanced level and you didn't go into detail like how this parameterized query works, like as a developer you just used it and you are not sure like how this exploit happen, or even if you are an AppSec engineer and you don't know the details how um, um, this works behind the scene. I think it's very important to understand it, and it is like kind of a one of the very important questions normally comes up in all the AppSec engineer interviews. Like I personally ask this question whenever I do the hiring, and yeah, I think it is very important question. So in terms of the parameterized queries, the first step is like the separation of the code and data. So a SQL code and the data is actually SQL code is your SQL query set static from all that thing, and data input and data is the user inputs, like which are sent to the database separately. The SQL code is predefined and does not change based on the user input. So whatever the user input is coming up, that does not affect the code part of your query. Only the parameter are passed to the database. So you have the code predefined, and the data is coming as a separate parameter, not like as a when you do the concatenation, you concatenate and it goes like a one string to the database. Whereas um, in terms of parameterized query, it is come as a pre-compiled query. So the next second one you look at over here, when using the parameterized query, the SQL query is pre-compiled by the database server. This means the database understands the structure of the query beforehand and can optimize its execution plan. The parameter are then separated into the pre-compiled query in a safer manner. So the query is already compiled on the server. The user input comes, and that has been handled at the database level, not at the front end level. Whereas you are concatenate the query and then you send the query to the database to compile it. Whereas the parameter query is like the pre-compiled version of that query. Automatic escaping, parameterized are automatically escaped by the database driver or API, whichever you like you're using. So escaping ensures that special characters like code, semicolons, and the one which you just saw within the user input are treated as literal characters rather than the SQL code. This prevents the attacker from injecting malicious SQL commands. So for example, if you are using a parameterized query, so your query is already pre-compiled. When you pass that data, it goes into your database, and if you are using like a single quote or double quotes, those are treated as literal character than SQL code. They make sure like it's not like a SQL code. It's a character which coming up inside your data. So that's where this query breaks, and that's where the error comes, and that is like one of the best techniques to avoid the SQL injection. uh, let's have a look the second one, which is second order SQL injection. Most of the time, people confuse this second order SQL injection with the stored cross-site scripting as well, which is rightly so. So first, let's understand what this second order SQL injection is and how it is different from the stored cross-site scripting, which I will cover up as well today. So again, it is a type of SQL injection where malicious SQL code is injected into web application and stored for later execution. So whereas we looked into previously, which is like the normal SQL injection, that is happening right there when you are inputting the value, you are fetching the information, you are injecting some codes into this one. Whereas the second order SQL injection, you put your code inside the database, but that code might be executed later in the user journey. So that's where the main difference is. The second one is the stored payload. Again, the injected code is stored in the database and potentially as a part of the user profile or a comment or any other stored data. That is to be executed later on. So later, whenever the stored data is retrieved and used in another SQL query without proper sanitization or parameterization, the malicious SQL gets executed leading to the potential data breaches, manipulation, or harmful action. So these are like kind of a three-step for this second order SQL injection. Let's have a look this example scenario. So the first one is injection point. The attacker register a new account with the username that contain the SQL code. So insert into username, email, password. Username is attacker, email address, and then the password. Suppose attacker input this thing, single quotes, close bracket, colon, drop, table user, colon, dash, dash. That is like for comments. The final SQL query would look like this. So the first part remains same, and then the values. You see like this value has been closed over here. So that query has been completed over here. When you put the colon and then the second query started. So next query started is drop users, drop table users. And then rest of the part of the query, when you put this thing, rest of thing is coming up as a comment. So SQL ignore that one. So the stored payload is this one, which is single quote bracket colon drop table user. Hyphen is stored in the username field in the database. So whenever you execute this one, so let's have a like the trigger execution. So later when the application retrieve the user's username from for some operation, such as displaying user profile or processing user data, it might construct a SQL query using this stored data without proper sanitization. So select static from user where username is equal to their username, and then the username is coming up as this one, like colon bracket single quote bracket colon drop user. So if the application uses the unsanitized username directly, the stored malicious payload get executed, dropping the users table. So that is like kind of a thing which is stored in your application, and then user executed later on whenever you do something else. So that's what we call the second order SQL injection. Now the question comes how to prevent this thing. One thing I would like to add over here, nowadays, like there are a lot of applications using AI, and then there are a lot of applications which we are building as an AI. Regardless if you're building an AI application, using AI in your application, or you're using the normal application, these 5 points remain same. So use prepared statement, parameterized query so that your data and the code are separate and they treat to be separated. Sanitize input data, sanitize all users input, ensure that any data stored in database does not contain harmful SQL code. It is very important, like sometimes when we do is we do all the validation on the front end. So for example, when we getting the username and password, we do all our validation there. Once it's been stored in database and we retrieve it later on for different operations, we didn't look into the fields again. Whenever you use any data anywhere, used it from your database, used it from your models, LLM models or APIs, always sanitize, always validate it. Don't blindly trust if it's coming from a database, if it's coming from LLM model, it is secured. No, always sanitize it, always make sure let validate it. And then escape data correctly before using it in the SQL queries. Although parameter queries are preferred way. Yeah, I mean, if by somehow if you are using a legacy application which is not possible to use the parameterized query, then make sure you are escaping your data. Validate and encode output. Validate and encode data before displaying it to the user to prevent cross-site scripting attack, which can be used in conjunction with SQL injection. Least privilege, I already talked about it, and I always mention like it is kind of one of the most important thing in the designing an application. So let's have a look the key differences over here. Let me move myself. So if we compare the second order SQL injection, which looks same as the stored cross-site scripting, which is right, but there are a few key differences. When you go for your interview, make sure like you go through this slide, because it is kind of like a very common question come up in a lot of interviews. And that's where I see like a lot of AppSec engineer sometimes fails in an interview as well, because if you are like advanced level in your career and you don't understand the differences, it is kind of a thing like, the SQL injection, you have your knowledge at the top tier level, but you don't like see what things happen behind the scene. So you have some knowledge, but you don't have the details around it. So it's very important to understand the key differences between them. So let's have a look. The first one, which is like a target, the database and SQL queries, obviously like in a second order SQL injection, whereas in the stored cross-site scripting, it's the browser and client side scripts. Payload and storage, stored in the database to be executed later in different query, whereas the stored cross-site scripting is like stored in the database to be executed in the user browser. So that is the key difference. Like one is being executed in the browser and the second one is executed in the different query. Initial attack vector, input field that interact with the SQL queries. Again, input fields that render content in the web pages. Execution context, one is executed on the server side, database interaction. The second one is the client web browser. Primary impact, data manipulation, unauthorized access, data loss. Over here it's data theft, session hijacking, defacement. Common mitigations around it: parameterized queries, input validation, and sanitization. Obviously, like when you're displaying any information, make sure you encode your output. Input validation, content security policy. So these are like, if you look into the basic one, which is input validation, is stay same in both of those two. So if you validate your input, you can mitigate both these vulnerabilities alongside with all other controls which we just talked about it. Again, this was another important topic, or a question comes up during the interview calls as well. Why we need parameterized queries when we have a WAF available? Web application firewall can handle it. We don't need to do any changes in the code. So my answer to that one is, like WAFs are the pattern based, not logic based. So how modern SQL injection bypass signature detection. So let's have a look at the traditional WAF. That is like a pattern matching. Over here you see like single quote or 1 is equal to 1. The WAF will validate it because that is like kind of a pattern matching. Whereas union, you are adding like a single quote and union. So these are like kind of a normal things which normal WAF looks for, like user signatures and heuristics, block obvious and outdated payloads. Whereas the modern logic based attacks, bypassing WAF, encoding tricks. I mean, if you encode your input, they're not able to understand. JSON based injection, which is very common. Nested objects, which is linked with, like the time based SQL injection. Case manipulation, white spaces bypass, SQL functions, case and sleep. So let's have a look this one, like select static from user, and then you put your single quote and concatenation, select case when 1 is equal to 1, then page sleep. And attacker can use like complex and obfuscated logic to evade the pattern detection. So that's where like the traditional web application firewall won't work. Now let's have a look like how SQL injection happen behind the WAF. WAF protect like public endpoints, but modern apps have internal API, microservices, admin panels, mobile app backend, GraphQL endpoints, webhook, internal tools. So if an injection exists, internal service to service call, private API endpoint, admin only functionality, the WAF never see those things, like, and if they don't see it, then they cannot protect it. So that's how, like if someone says to you, like if we have a WAF, why would need the SQL injection? So these are all the reasons, like you need to implement the mitigation techniques for the SQL injection, even if you have the WAF in place. Now let's have a look this example where the logic based is not like same as the signature based detection. So modern application is not always obvious string concatenation. Let's have a look this bad code. You have a query over here which is select static from user where ID is equal to user input. If user input is expected to be numeric, like 1 union select password from users. What if it's a JSON? Like you can pass ID, where you can pass this thing ID is 1 union select password from users. So those like the user input is expected to be numeric. If backend parsing the transform it, the WAF might miss it, because it looks legitimate to me. There is nothing as such which can match the pattern in your WAF, and that's where the WAF can miss it. Cloudflare is not like a secure coding, like Cloudflare is just to filter the traffic, blocks known malicious requests, provides rate limiting, which is very good about in those things, stop obvious exploitation. It does not fix unsafe code. It does not enforce the parameterized queries. It prevent insecure dynamic SQL queries. It where it does not. And the same with the secure internal services as well. So if you are using like a normal SQL injection or second order, whatever, you're doing, make sure like you do the mitigation techniques which we discussed earlier on, like this one, like make sure you're using the parameterized queries, stored procedure, input validation, and least privilege. I hope you learned something today. If you like this video, please subscribe to my channel and press the bell icon. Thank you.